the previous, just to give you a recap of the previous week, we discussed about the terminal of how to execute commands and how to interact with the shell with the OS and get the commands output, and basically creating files, moving files, naming files, etc. was all done through your terminal only. So major part of your work in Linux will be based on the terminal only, but you should also learn about the file systems. For example, if you remember, we moved into slash etc slash maybe bin and slash root or slash mnt. There are many directories. What you say? These are the predefined directories which come with Linux. So it's important we know them so that we can understand what exactly is every directory and which content. Like for example, if you create a file or a code, you should know where to put it exactly. Or if you want to configure something in your Linux machine, and maybe for example, let's say you want to connect, like if you have faced some problem in Bluetooth and you want to configure it somehow, so you have to know that what's the correct directory to go into to find the Bluetooth configuration options in your Linux machine. So basically, to just summarize, the C partition, which in Windows, which it comes, if you have known, it's the alias for this slash the root partition in the Linux. So just wait and hang on, and you'll know more about the file system here. So our previous session was about the terminal, and this system, it's knowing about the like the Linux system. We'll also go through the GUI here for the first time, so you'll get to know where exactly files are located, how to do over the GUI also. So here we have the file system, and here it's the hierarchy which Samit will be discussing. We're also talking about the symlinks and maybe how to create some basic files. And with that, then we'll move on to users, group, and permissions. This will be taken by Sachin. And this basically talks about how many users can you create in your machine. For example, your machine is this. I was talking about the local user and the root user in the previous session, which is maybe my name is Veleshwar and the root user is the admin, which is the admin of the system is the root ROOT. So maybe you can create more users. For example, if you just want to test a database with your system, so you can create a user called as Oracle or MySQL or something. So you can create users like that, and also you can create groups, which we'll be seeing in details. We'll also seeing the permissions about some files and directories. And lastly, we'll be looking at the processes. So I'll just tell Samit to start.
For a computer, the data on a disk is just a blob of ones and zeros. The computer doesn't know where a file ends, where it starts, any of that. So to make sense of that data, files on disks are stored according to a set of rules. That 8 bits is 1 byte, how those bytes are stored, and how files are arranged, how files point to one another, all of that. And all of that, that set of rules and that system of arranging files is called a file system. And there are a lot of file systems. Some of the most common ones I've told here. First is FAT, which is the simplest. It stands for file allocation table. And earlier it was used by DOS and Windows, older version of Windows. And nowadays, it's because of its simplicity, it's mostly used by portable storage systems. So memory cards, pen drives, and everything like that will use FAT. Then there is NTFS, which stands for New Technology File System, and it's not new now, it was new back in the day. And this is the main file system used by Windows. So if you guys have a hard drive formatted by Windows, anything in there is stored according to the NTFS file system. Then there is the ext family. By family, I mean there's ext, ext2, ext3, ext4, and maybe other versions in the future. So ext, or the extended file system, and this file system is used by most Linux distributions and other open source software. And ext is open source, whereas NTFS is proprietary. So anyone can use ext. You can even download and modify it. You can't do that with NTFS. Okay, so this is what a file system is. And another thing about Linux, you need to know that everything is a file. When you connect a device, how does the OS know where the device is, and how will you communicate with that device? And in Linux, what happens that any device, IO device, any network adapter, and by IO devices, I mean even the keyboard and the mouse, everything is represented by a file. There's a directory in some folder where you can find a folder or a file with the name of your device, and when you need to talk to a device, you don't directly talk to it. You just write data to the file, and then the OS handles everything else. Oh, this file is a representation of this hardware, so I will send this data to that hardware, and everything works out in the OS, and you can simply interact with anything as if it's just a normal file. This is a very important concept in Linux, that everything is a file. So, and even processes are a file. So any program that is running in the background, that is represented by a process. If you use Task Manager in Windows, you can see a list of processes and you can kill them, end them, anything. So even those processes are represented by a file. So everything in Linux is just a file, which makes it very easy to interact with anything, because almost in every language you can use files, and thus you can use OS functionality very quickly and very simply in Linux. Now we move on to the FHS, or the File System Hierarchy Standard. Now what this is, it's basically a set of directories. It's a hierarchy of directories which is more or less followed by every Linux system. If you use Windows, you would know that Windows drives and folders are organized by drives. So something is in the C drive, so the path of it will be C:/ and so on. And if something is in the D drive, it will be located in D:/ and so on. So in Linux, everything is in a single tree, and the tree, all of the directories start at the root directory, which is shown by this single /. This is the root directory, and it is at the top of the tree. Any file you can imagine in your operating system will be going under this directory. So it's called the root. Okay, and any proper path in your system, any proper path will start from this /. If in Windows, you might know, if you need to specify the path of a file, you will be writing C:/ the folder and the file. In Linux, everything starts from root. So /. So every path starts with a /. And Linux uses // to demarcate directories. If you're in Windows, it normally uses \. Okay. Now, according to the FHS, there is a set of standard directories inside the root directory, and these contain a lot of system essential, user essential, program essential files, and I would advise you to just look at these folders, but don't mess with them unless you know what you're doing. Okay, so first we have the bin directory. I'll show you these directories. Okay, so I'll show you in the terminal. So right now I'm in my home directory. Okay, this tilde character, as we have told before, it means home. So now if I do pwd, you can see the current path. It starts from root, then there's the home folder in the root, and inside there is my folder called SAM. Now and you guys know ls is the command to show all the files in any directory. I will give it the flag /-l, which means that we need to see the output in long format, which is a list with a lot of extra information, and then I'll give it the argument /, which is the root directory. So I'm telling the terminal to show me all the files in the root directory. Now you can see a lot of files, bin, boot. We'll talk about them, and you will even see these arrows pointing to other files. I'll even talk about that. Okay, so here you can see the contents of the root directory, and there's nothing root above root. If I cd to root, okay, I can see everything in here. But if I try to go one folder up, it just won't go, because there's nothing above the root folder. The root folder is at the top of the tree. Now, first we have the bin folder. Now the bin folder contains binary files for every user. If you don't know what a binary file is, it is basically an executable file. It can be an executable file. So if in the terminal we do ls bin, you can see there's a whole list of files here. These are all the binaries, all the executable programs that that any user will need to run properly. So these are needed for every user. So these are system-wide binaries which are used by users. So for example, when you type ls, what is ls? ls is just an executable file. It's just a binary file. It's a program located in the bin directory. And if I do ls bin, and if I can scroll up to L, you see in the bin directory here you can find ls. So any command you use, most of these commands would be located in your bin directory. You can even see cat here. Yeah, cat is here. So you use cat to see files. So cat, bin, ls man, everything you want to see is in the bin directory. Any software you use is usually in the bin directory. Any system command you use. Now the boot directory contains the kernel, bootloaders, and other essential files to boot the system. So when your computer is being switched on, the operating system is in the disk, and you need it, and you need all of it in the RAM so you can run a system. So your kernel, bootloader, everything needs to be loaded, and everything that needs to be loaded at boot is in the boot directory. So do not mess with this directory. You will break something. You delete one file, your computer might not switch on. So be careful. I don't think you would even be allowed by Linux to do it. Okay. So in dev we have device files. So as I told you, everything is a file. So even a device, any keyboard, anything you connect is a device. So the dev directory /dev contains all the files which represent devices or device files. If we do ls dev, you can see that you can see the NVMe slots or whatever here, and TTY are text terminals. So you can see all the terminals which can be connected. So I really don't understand this completely, but see, there is a file which represents the CPU of the system. So anything in the system is represented here. You can see the standard input, standard output, and standard error files. So if you guys know, whenever you print something, you write it to this standard out file, and writing to the standard out file, after that the OS handles everything. It handles showing the screen, showing the text on the screen, sending the correct characters, coloring it. Everything else is taken care by the OS, and you just need to write to this file. Now we come to etc. The etc or etc directory contains configuration files. So if there is an important software running in your system, and you need to configure it, and you don't know where the config file is, it's worth looking in /etc, because it's most probably going to be here. So if we check out the etc folder, ls etc, you can see any file that ends with rc is usually configuration files: bash rc, vim rc, prettier rc. So you can see, and you can see a lot of .conf files. This is also a configuration file, .config. And yeah, so this folder contains everything configuration related, and it's basically miscellaneous stuff. That's why it's called etc. So next up we have the home directory. It contains the home directories of all the users. So if you're a user, if you're logged in, your home directory /home /user /your username, that directory gets alias to the tilde directory, and that's how you access it. That tilde is also inside the home directory. Now there are a lot of lib directories. You will see here. If I do lsl, you see these lib32, lib64, libx32. All of these are essentially libraries which are used by binary files. So any program, so when you write a C program, you access some libraries, right? You include something at the top. You tell the preprocessor to basically copy that code from that file. So where is the library file? Those files are located in the /lib folder. These folders contain every library you're going to use, or at least the basic ones. So yeah, bin and sbin are two directories which hold binaries, and the libraries used by them are here. Now in media you will find any external IO device, basically removable media. If you insert a pen drive, the path of that pen drive would be in the media folder. And MNT has mount points for temporary mounted file systems. It basically means you can mount your drives here every boot. So it's for mounting. So if you see in my folder, if I do ls mnt, you can see two drives, which is SAM and Windows. So Windows is, because I dual boot my system along with Windows 10. So Windows is the C directory, is the C drive of my Windows partitions, and SAM is the D drive. And I have mounted both of those in the MNT directory. So these are temporary file systems. They go away at every boot, and I mount them at every boot. So I mount them at MNT. OPT contains additional packages. This is not very important right now. /proc. I told you every process is also a file. So any process running is a file. So if I do ls-proc, you can see the process IDs of every running process in the system. So a process ID or PID is basically a representation of any process. So if you see the currently running processes, you can see their IDs 58. So you can see 5884 is here, and I think we can find, and you can find 5884 over here. So any process you can see in that system monitor, you can also see that in the proc directory. Okay. After that, you have the root directory. This is the home directory for the root user. Simple as that. So for normal users, the home directories are located in /home, and for the root user, it's located in /root. And the root user is similar to an admin in Windows. You'll learn more about the root user and all the users in Linux, like after me. SBin contains system binaries. So bin contains binaries used by the user or any user. SBin are binaries used by the system. So you don't want to touch that. So this is the OS uses them. And SRV contains files used by servers. So if you're running an FTP server, an SMTP server, anything like that on your machine, /SRV will store those files. And /sys contains important device information. Okay. /tmp contains temporary files. So if you're copying something and if any temporary action is happening and you need to write some data temporarily, and then you want it and you don't want it stored forever, you write it in the temp directory, and at every boot and reboot, the temp directory gets cleared. So you can't count on the temp directory data being persisted. And /user contains a secondary hierarchy for read-only user data. And /user usually contains a lot of folders similar to the root directory, to the / directory, not this root directory, this root directory. And if we see ls user, you can see bin, lib, all the lib folders, and the sbin folder and the src folder. All of these folders, which are also located in the root directory, are also in the user directory. And if I so this, you'll see that the lib directory in this folder has an arrow pointing to the lib directory in the user folder. I'll tell you what that means in a moment. And /var contains variable files. /var also gets deleted, and it's basically for logs and spool files. So if you have a program running which logs something, it's usually going to be located, the logs are usually going to be located in the var folder. Okay, so lib points to user lib. Okay, lib32 points to user lib32. Why is this? So the FHS standard is maintained by the Linux Foundation, but they don't enforce it. They just tell it, this is because it's all open source, anyone can do anything. It's true freedom. So they just say, we have the standard, you can follow it if you want. But many distributions choose to deviate from it a bit. So they basically consolidate the lib and the user lib folder. So the lib folder is just basically a shortcut to the user lib folder. If you access the lib folder, you are basically accessing the user lib folder under another name. It's basically a pointer. It's called a symlink, and I'll talk about that later. But this is a symlink or a shortcut to this folder, and in some distributions, all of these are consolidated to a single folder. So all of these, and even the other user lib folders, are aliased or symlinked to user lib. So this is a place where many distributions deviate from the standard. And in my operating system, which is Pop OS, which comes from Ubuntu and originally from Debian. So these are the 5 symlinks I saw. SBN goes to user SBN also, and all the 4 I talked about. Now we come to file types. What kinds of file can you have? First is plain text. Everyone knows what a plain text file is. A .txt file in Windows or even in this Linux. And yeah, to create a new file, which is a plain text file, you have a simple command called touch. Let me go to my home directory. Okay, you can see these 5. You can see the directories of my home directory, the contents of my home directory right now. And if I do touch hello.txt and then see the contents, you can see the file gets created. As simple as that. So if you need to create a text file anywhere in the terminal, use the touch command. Touch space the name of the file. Now we come to binary files. Binary files contain raw binary data. So a plain text file also contains binary data, but it is usually in the ASCII or UTF or any text encoding format. So the computer knows, okay, yeah, this byte means this byte means this. But a binary file does not contain text encoding. It contains instructions. It can contain instructions for the CPU. It can contain music. Okay, so a representation for music. It can contain an image, a video, anything. So you can't read it normally using a text editor. You have to use special software for that. So if you have a music MP3 file, it's a binary file. Okay, it doesn't contain text data. It contains some other data which only a special kind of software or something can read. That is a binary. Now we come to directories. It's not really a file, but I've put it in the same heading. A directory is basically a folder. You all know that. So if you need to create a directory, the command is mkdir, make directory. Now if I make a directory called sam and ls, you can see a new directory, sam pops up. Okay, so touch and mkdir are 2 commands you will use to create new files. Now symlinks. Okay, as I told you, symlinks are short for symbolic links, and these are shortcuts to another file. If you used Windows, you know shortcuts, and they link one directory to another directory or one file to another file. Okay, and there are 2 types: a hard link and a soft link. A hard link, basically, the only difference is a hard link cannot be created for a file in another file system. So if, like me, you have an NTFS file system, so as I showed you, in my MET folder, there are 2 drives. There are 2 folders mounted, SAM and Windows. Both of these are also used by Windows, my Windows installed. So both of these are according to the NTFS file system. So I cannot create a hard link to a folder in SAM or in Windows. Okay, but I can create a soft link, and a soft link is basically a symlink which can be to any file you can access. And symlinks are represented in the long format, the long ls format by an arrow. And you can see these are symlinks that I use. So what I've done, there is a VIT folder in my home directory which points to the VIT directory in the MNT SAM directory. So in the other drive, if I go to CD MNT SAM and I show you the content from there is a VIT folder over here, and there is a VIT folder in my home directory, but this folder points to this one. So this is a simple shortcut, and you can use it very efficiently because, so like what I have done is that because I dual boot Windows and Linux, all of my user files are stored in a separate drive, in the SAM drive, and I link to that drive from both of my operating systems' home directories. So I can use the same data across 2 operating systems, and that is possible, and that is made more simple, and that is using symlinks. So that was all from my side. So I told you all about file systems and files. Now we have user groups and permissions.
Alright, so we saw a lot about how files work in Linux. Now I'll be taking another important topic, which is users, groups and permissions. So we'll just get started with users. So first of all, I think we all know what users are, right? If you are given a system, many people would like to access it and use its resources. But we cannot just let everyone do everything, right? So we need to differentiate between two people and the security implications of that. Like, not every person should be allowed to execute everything. So for that, we'll demarcate each user using the UID, or we create users and the system uses UIDs to represent it. So the UID is the number that the OS uses to keep track of a user, and every file has a particular user assigned to it. When you create a file, by default it is the creator who is given the owner, like that is a user assigned to it, but this can be changed as we'll see later. So in order to view the list of the users, we can just cat the etc password file. We'll see if I can do this. So let's just cat the etc user file, etc passwords file. And then we can see that we have all the users that are currently in the system. Now a lot of this is just even processes, they run as users in the system. We'll look at that when we come to types of users, but for now you can just see that these are all the users and you can find them in the etc password file. So yeah, and you can search who you are by using this command, using the whoami command, and it'll give you whatever your name is. You can also use the ID and it'll also give you a lot more information basically regarding who you are. So you have the UID, you have the group ID, you have the groups. This is the primary group and this is the secondary group. And remember that a user can only have one primary group. Usually it is created while the user is created, but this also can be changed later if you want to do so. So yeah, that is how you see the users and stuff. So we'll come to the types of users now. So there are three main types of users. First, you have the super user. This is basically the god of the system. You can do whatever you want if you're a super user, which means you have a lot more administrative capabilities and a lot more responsibilities if you're the super user. So we'll just look at that now. So suppose you're the root. The root user is often the super user, right? They have a different ID. The super user's ID is always 0. So let me switch into my now we are root, and if I do ID now, you can see that my UID is 0, my GID is 0, and the groups are also 0. I have not really started root because of security, but you can see that the UID is always 0 for this. Exit all of this. And then that is a super user. Then we have system users. The system users are basically they're assigned by the kernel. They launch processes, and because see, everything is a file in Linux, right? So similarly, even the processes, they run as users only, and the users, these users don't typically require elevated privileges, so they don't usually require root, and they're handled by the kernel to run stuff and to do stuff on your system. Then we also have our regular users, which are basically the normal users, I guess. They have a username and password, so you can just log in like that and go about your life. Those are our regular users. So now we'll come into managing local users. So by managing, what can we do? These are the system admin's responsibilities, right? So you can create a user, you can modify, you can delete, and you can change stuff. So we'll see how you can do that. Just play my terminal. Suppose you wanna create a user, right? There are two ways of doing this. You can either go for add user, or you can go for user add. Now add user is a more friendlier option, I guess you could say. So you need elevated privileges for this. So let me just switch into root. SU is basically switch user, or a sudo is super user do. So we are root now, and I'll create a user using the add user command. Let me guess, give me a name. Say So see, this is a friendlier alternative to user add, and it already does some things for us. So you can give some password, then you can just do whatever then you can create a user, and then you can check if this user has been successfully created by going to the cat etc. You can cat the etc password file, right? See, this is the some name the user we just created, and I'll also explain this. So basically, this is the name of the user is created. This X actually represents the password, and the olden days the password used to be stored in plain text over here, but of course that's a really bad practice, storing passwords as plain text. So now it's removed, but this shows that the password is indeed stored somewhere, and it's in the a shadow file. I don't think we'll look at that, but fine. There is a separate file that shows the password. This is this is the home directory of the user, and this is the does the same thing, but see, it does not do anything else for it. It just creates it, and it'll create a entry, but nothing else is still. You see, the entry is created. So that's that. Now to modify the user, you can use the user mod command. User mod. What all can we do? We can suppose I want to change the group. Alright, let me just create a group as well, right? You can create a group by the group art command. We'll come to this later. Right, so if I want to modify a user, I can just do user mod, then CG. This just means that you are appending a group, and the name of the group is group, and the name of the user. What is the name of the user? So we've modified the right. This is the GID. This is probably the GID. We can look into that by going into the etc in the group, right? So this is, see, whenever you create a user, a group is also created along with it. I think I said that, the primary group, right? So clear all that. So that is how you can modify the user using the user mod. And see, anything, if you have any doubts, right, regarding what all you can do, just go either man. You see, you can get a lot of information here, or you can just do this. Also gives you like a quick rundown of what all you can do. So yeah, that's how you modify a user. And then you can also delete a user by using the user del command. User del, you add this is kind of important. If you don't do this, the system does not remove the entry from the password file and the home directories. But if you use the -r, you can remove all the other things. So I think the name was some name, right? And if we start the password file now, then you can see that some user has been removed, right? And also delete the test user. Is that what I would call that? Yeah. Anyway, that is how you delete a user. So, and you can also change the password for users by using the passwd command. Wait, I deleted the user, but anyway, it's really simple. You can just use, if you just go password then it'll ask you for your own password. So this is if I want to change the root's password, which I don't want to do. This closes. So anyway, that is how you change the password. And these are some of the commands that we just saw. Who am I to print the current user's name. You can use the ID for the real and effective user and group IDs, giving more information. SU to switch users, if you want to switch users, basically it's pretty self-explanatory. PS is to show the processes. So if I do PS and supply this, it will give you like a list of all this is basically process snapshot. You can see which user is doing what process. So I have root and 00 is my user ID. So that is PSU, and LS AL to list out all the files. I think we already saw this. LS AL, then this, it gives you all the details regarding the files. This is what AL will also give you the hidden files. So that's the difference. Alright, so coming on to groups. What are groups? Groups are basically just a collection of users that need the same access to some file or some resource. So again, just a collection of users. So the OS uses a number, again similar to the UID. We also have a JID that keeps track of a user's group. So system groups, we have JIDs between 0 and 999, and then user groups will have 1000 plus. So you can assign a JID manually, but you have to keep this in mind, because if you have a JID which is between 0 and 999, you might cause some conflicts. So to avoid that, just give some higher number. So yeah, to view the groups, you can just cat the etc group file. I think we've already done this for something, but I'll do it again. So this is the group. So similar to user management, we can also manage groups. You can create a group by using the group add command. The group add, basically, we did this also, but yeah, the -r in this case is so that the system will assign the group ID automatically. So we can just something. Oh wait, yeah, of course you need sudo. You need to do sudo. These are all sysadmin tasks, so you need super user access. Right. So I think we have created a. See, we have created a. Some things it is fine, when it's fine. Then to modify a group, you can just use the group mod. So suppose do group sudo on, and then we need a new name, right? -n to change the name, new name, and then you supply the old name. Now if you cat the file, this new name. That is how you change the thing. Again, you can do this, and you can find all the options that you can use. You can play around with this on your own, and we'll learn more. So that is how you do that. To delete a group, obviously, like we did before, it is group del and cd. I keep forgetting. Group del and whatever is the name of. It does not exist. What did we name it? New name, alright. Then it deletes it. Got it? It's gone. So that is how you can, add or remove and manage groups. And if you want to add a user to a group, suppose, let me just create another add user. So add some name. see if it is there. Yeah, we have created a new user. Now we'll see if we can add this user to some, which group have I deleted. So yeah, we have this name group, right? You can just add it to that. To add a user, you have to modify the user, right? So you use that command, user mod -ag, whoops, ag. And then the name of the group. The name of the group is name of the user. What do we call the user? We also call the username. Alright. Use sudo stuff. Yeah, this is a new one. Anyway, that's how you do it. And something you should keep in mind, you're using AG because A is for append, right? If you don't do this, you'll override whatever groups are already in there. So you just have to be careful of that. Don't use, and capital G is for the secondary group. So yeah, that's how you modify a group. You can add users, you can delete users. Then also, yeah, if a group is some user's primary group, then you cannot delete that group. So you might want to keep that in mind. Then capital G for secondary group and small g is for the primary group. So we'll be moving on to permissions now. So what are permissions, right? Permissions are basically used to, give or restrict access to whatever, to files or devices, whatever. So there are 3 categories of file permissions as well. So it can either be owned by the user, you can either be owned by a group or by others. Others are basically people who are neither the user or the group. So everyone else comes under others. So the more specific the permission you give, the higher the precedence. So user will have higher than group and that will be higher than others. So permission categories, we have read, write and execute. So if you are talking about files, read means, as the name implies, you can read the contents of the file. For directories, it means you can list out the contents of the directory. For write, it means that files could be modified, and directories files mean files could be added or deleted. If you supply X stands for execute, you can, run the file. And in directories case, you can make the directory a present working directory. But you need to keep in mind that even if you have the X permission for directories, if the R permission is not given, you can't view the files. So you need R and X to view the files. So right, changing permissions. To change the permissions, you can use the chmod command. We'll do that. Just list out my contents. I'll create a new file. Right, to check the permissions that stuff currently has, you can just do it. And this will give you that we have, the dash in the beginning signifies that it's a file. The RW signifies that you can read, write, but there is no execute. Then the first 3 bits are for the user, the second 3 bits for the group, and the last 3 for the other group, for the others, right? So the user has read, write, the group has read, and the others also have read. That is what this means. You can also do ls-l and you can see it for everything else as well. Alright, now how do we change the permissions, right? So there are 2 ways of doing this. 2 notations, I suppose. You can either go with the symbolic way, which is you use words like G, U and O. G for groups, O for others and U for user. And then you can supply using plus or minus. Plus means you are adding a permission, minus means you are removing a permission. And then you can just go about doing that. Something like chmod G O minus RW means you're changing the mode. For the group and others, minus, you're removing something, you're removing the read and write permission from file 1. So we can do that as well. See, what would I call it? Alright. So this is the current permission, right? You do need sudo for this. So sudo chmod. We are going with the symbolic. So go. So removing read write from test file. You do this again. You see all those permissions are removed. You can also remove this if you want. The user. See, there are no permissions now. So that is the symbolic way of doing it. And then we also have the octal, the numerical way, which uses the octal system. This might be a little tricky to explain, but let me try anyway. So the order is read, write, execute, right? So these are represented by 3 dashes, suppose. And you guys know the binary system. So if you are enabling something, you give it a 1, and if you're disabling something, you give it a 0, right? The first bit of the numeric stands for the user. Second bit, this stands for the group, and this stands for the user. For the others. So suppose you want to give them read, you don't want to give them write, and you want to give them execute. So what would you do? You would put 1 here, 0 here, and then 1 again here. So which will be 101. 101 is binary, and 1012 octal would be 5, right? This is 5. So which means you're giving R and X to whichever one you specified. I'll show to you on terminal as well. So this has no permissions now, right? Suppose I want to give read and execute to the user. So that is 101, right? 101 would be 5. And then for the group, I want to give him read and write, suppose, which would be 110. 110 is 6. And then for the others, I want to give them nothing, which would be 0. That's it. And then just supply the name of the file. See, we give it's a file still. Read and execute for the user, read and write for the group, and nothing for the others. That is how you use the numerical way. System administrators usually prefer this because it is more concise and going for something like this. So yeah, that's about it for chmod. So if you look at the ownership, alright, we'll talk about the ownership. So the ownership is now given by whoever created the file, right? This is the default setting. You can change this using the chown command. So you can use chown with sudo, of course. So let me see if I have some users or not. If I have to create it again. So we'll just start. Right, so we have one user called name. Fine. Suppose I want to change the owner. So what will I do? I'll use the sudo command, of course, chown. It auto completes, right? And then the name of the user that you're changing it to, you're supposed to give it here. So it'll be name, and then colon. Colon is if you want to change the group as well. If you don't give this, only the user will be changed. See, the user is now name. If you want to change this, you have to give it with colon. The group name goes here. In my case, I think the group is also called name itself. See, both of them are now changed. So that's how you change ownership. And another important thing that I forgot to mention, when you create a file, by default, it's never given the executable permission. So you have to go and do chmod and give it some executable permissions if you want to execute it. Right. And I don't know if I've covered this here, but you can actually change the default setting as well by going to something called umask. Do umask. You can use the umask to check which all permissions should be given when you create a file. Right. So yeah, that is how you change ownership. Colon signifies the group. Okay. Then we have some special permissions. So special permissions basically, now we have seen for read, write, execute, right? You can also there is also this thing called S and T, which is the special permission. What it does is, if you are giving it to the user, how it affects the files is the files would execute as a user that owns the file and not as a user that ran the file. So this is the effect on the file. On directories it has no effect. So what this means is, as an example, you can check out the password command, right? Let's see where it is. So if you do /l / as you can see, this we have this S over here. This S means whoever is executing it, it executes as whoever is the owner. In this case, it's the root. So suppose you're not a privileged user, but you still want to change your password, right? You should be allowed to do that. So you can use this command, and to change the password, of course, you need root access, and it will run it as root. That is what this does. So similarly, as gid, you can append it to the group, and what it does is the file executes as the group that owns the file. So similar to whatever was done with the user. So on directories, the effect is that the newly created files will have the group owner set to match the owner of the directory. So sticky basically what it does is, on files it has no effect, but on directories, if you have write access to the directory, you can still only remove the files that you own. You can't remove files that other people own, which is what the sticky permission does. So this also can be set either numerically or using our symbolic expression. Let's try to do that. We have our test file, right? This has all these commands. So let's try giving it some. The first is remove all permissions. No permissions now. Alright. So let me add something. Sticky. Using the symbolic way, what you can do is user. I'm adding to the user, adding S. See, okay, this capital S comes because you haven't given the user executable permissions. If we do that as well. Now it's small s. You can also do that with the other like for U is for user, and you can couple it with G. Where is it? Yeah. So you can use G here to mess with the group settings, and O for the other settings. Not typically how you do it. Using the numerical method, you can also do this, and for that, if you are giving it the S, this U plus S, you have to supply 4, and to set the GID you supply 2, and for sticky you supply 1. So what that basically means is, suppose I want to give it to the group, right? So I'm going to set the GID. For GID it is 2, so we'll give 2 and then regularly whatever is regular. Let me give 7, then let's say he can have read and execute, that's 5, and then this guy can have nothing. test file. If we do that, you see the group has the S parameter now. So yeah, that is how special permissions work, and you can also set this numerically or using symbolically, as you just said. So on to process, but I think we've run out of time. So processes,
Yeah, we'll be taking process in the next session. No worries on that. But I would say it was really great hearing from you, Samved and Sachit. I would say I personally also enjoyed your content, both of you. Like the file system was top notch, as well as this user, the ownership chmod was great. I loved your tutorial. So yeah, we will conclude the session for today.